Hey, welcome to Algebra 1. Let's talk about graphing linear inequalities. So far we've learned how to graph equations like this. This one's in slope-intercept form, where the slope is in front of x, so the slope here is 1/2, and the y-intercept is added on to the end. So the y-intercept here is -3. So let's remind ourselves real quickly that slope is 1/2, and the y-intercept is 0, -3. So here's our y-intercept at 0, -3, and then a slope of 1/2 tells us we're going to rise up 1 and go to the right 2. So from here, we're going to go up 1 and to the right 2 to this point. And then, since it's all the y values that equal that, we're going to draw a line through here. So when it's y equals mx plus b, we're drawing a solid line. So what happens when we're not just using a linear equation? The equal sign means equation. What do we do if it's a linear inequality? Like this, y is greater than or equal to 1/2 x minus 3. We're still using the same kind of formula over here to define the regions. Notice that when we graph this line, it cut the plane into two parts. You got the top part up here and the bottom part down here. And since we have y by itself and y measures up and down, we're always going to think about what's above the line and then what's below the line, because y measures up and down. And if y is greater than this line, then we're going to be shading above the line. If it said y is less than, then we would be shading below the line. So why do we do that though? Why is it that we shade above this line if it's y greater than or equal to? Well, let's go back to the line. This says that y equals 1/2 x minus 3. That means we can take any x value and plug it in, and the only y value that we care about is the one that equals 1/2 times that x value minus 3. So let's look at the x value 2. Here's the x value 2. If we plugged in a 2 here, half of 2 minus 3. Well, half of 2 is 1, and 1 minus 3 is -2. So when x was 2, y was -2. And that gives us this point right here. But it's only that one point on that line. If we put the x value of 2 into this inequality, we get y is greater than 1/2 of 2 minus 3. We get y is greater than or equal to 1 minus 3. So y is greater than or equal to -2. So it's not just that y equals 2, it's also y can be greater than -2. So when x was 2, so here we are at this x value of 2, the y values can be greater than or equal to 2. So we need to count all these points up here. All the points that have an x value of 2 and a y value that's greater than -2. So for every x value, that's what's going to happen. If we plug in 0, we're going to get y is greater than or equal to -3. So we're going to have all these points that have the x value of 0 and a y value that's greater than or equal to -3. And that works for every single point on this line. So every point above this line and on this line is a solution to this inequality. Well, what about if it was y is less than 1/2 x minus 3? How is that different? Now, for every x value, we think about our y value is going to be less than or below this line. So if we were to plug in the x value of 2, y is less than 1/2 of 2 minus 3. Y is less than 1 minus 3. So y is less than -2. Now, we're not including the line. We're just kind of skipping the point on the line and then counting everything below it. And that's going to be the same with any x value you pick. You're going to be skipping the value on the line but everything below it counts because our y values are less than where this line is. So you end up shading everything below this line, and then the way we show that the line isn't counted is we draw this as a dashed line. So if it's just less than or just greater than, it's going to be a dashed line. If it's greater than or equal to, then it's going to be a solid line. And here's a way to remember. You can write this down in your notes. If it's y less than, you're going to shade below, and it's going to be a dashed line. If it's y greater than, you're going to shade above, and it's going to be a dashed line. If you have y less than or equal to, you're going to shade below, and it'll be a solid line. And if you have y greater than or equal to, you're going to shade above because it's greater than, and then a solid line because it has the equal to sign. Now let's see if we can match the linear inequality to its graph. This one is y less than x minus 1. And if you notice, they all have y on the left side and they all have x minus 1 on the right side. So all we really need to look at is the inequality sign. So y is less than. We're going to be shaded below because it's y less than, and it'll be a dashed line. So this one is shaded below with a dashed line. Ding! Less than or equal to. This one will be shaded below because it's less than, but it'll also have a solid line because it's less than or equal to. So this one has a solid line and it's shaded below. Here's greater than. Y is greater than x minus 1. Greater than means we're going to shade above. This one is shaded above, and this one is shaded above. But if it's strictly greater than, then we're going to be shaded above with a dashed line. And if it's greater than or equal to, we'll be shaded above with a solid line. So, which one of these graphs gives us the graph of the inequality y greater than or equal to x minus 1? Well, greater than or equal to is going to have a solid line because of the equal to sign under here. And then the greater than says that we're going to be shaded above. So we're shaded up. So we want something where we have a solid line and we're shaded above. These two, C and D, both have dotted lines, or dashed, and B is shaded below. So the only option that we have left is A. It's a solid line and it's shaded above. It's the only one that could be the graph of y greater than or equal to x minus 1. And you can check the y-intercept and slope. The slope is 1, the y-intercept is negative 1. So we're intercepting the y-axis at 0, negative 1, and then our slope is up 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. How about this one? Y is less than negative 3/4 x plus 2. And if you'll notice on a lot of these problems, we have the same line here. We've got the same y-intercept, which is positive 2, indicated right here, 0, 2, 0, 2. And we have the same slope, down 3 over 4. These lines all have the same y-intercept and the same slope. But which one is shaded properly? If it's strictly less than, we should shade below, because it's less than. And since it's not equal to, it needs to be dashed. So shaded below and dashed is D. Now this one is given to us in point slope form. And all we really need to do is add 5 to both sides in order to get y by itself. Once we have y by itself, we can use our little rules. We're going to have y is greater than 2 times x minus 5 plus 5. Now I could multiply this out and simplify and get it into slope-intercept form, but all these lines are the same. So obviously my y-intercept is going to be -5, and my slope is going to be up 1, 2, 3, 4, 5, 6, and over 1, 2, 3. Up 6 over 3, my slope is 2. Well, there it is. But all I really need to know is where do I shade? And it's y greater than. So I need it to be a dashed line because it's not equal to. So it's not C and it's not D because those have solid lines. And since it's greater than, I need to be shaded above. A is shaded below, and B is shaded above, so it's B. Write the slope-intercept inequality for the graph below. All right, so it's going to be y something mx plus b, where m is the slope, and b is the value where it crosses the y-axis. We call that the y-intercept. So, and then the inequality sign we're going to get from solid or dashed and shaded above or below. So this is a solid line, so that means we're going to have the equal to sign underneath our greater than or less than, and we're shaded below, so that's going to be less than or equal to. So we got y less than or equal to. Now we need to find the slope. So the slope here, we go down 1, 2, 3, 4. So we're going down 4, and then we go to the right 1, 2. So our rise over run was -4 over 2. And that reduces to -2. So -2x is our mx. And then b is our y-intercept. And our y-intercept happens at 0, -2. And so the point is 0b. So our b value is -2. So -2x minus 2 is the inequality for this graph. Write the slope-intercept inequality for this graph. So now this one is a dashed line. So it's going to be y, and then we're not going to have the equal to sign under it. It's shaded above, so that's y greater than. Now we need to find our slope, and we can use the, if you don't want to use the counting way that I do, up 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6. And then say the rise is 4 and the run is 6, you can always do the slope formula. M equals y2 minus y1 over x2 minus x1. It's the difference in the y values divided by the difference in the x values, which is rise over run. So here's the difference of the y values. 3 minus -1. And then the difference of the x values, 3 minus -3. When you subtract a negative, it turns into addition. So this is 3 plus 1, which is 4. And this is 3 plus 3, which is 6. Which is pretty much what I said right here. Up 4 over 6. Rise 4, run 6. This reduces to 2/3. So our slope is 2/3. So we write 2/3 x, and then we need to add the y-intercept. Well, the y-intercept isn't given to us very clearly here, but if we count our slope is up 2 over 3. So if we start here and we count up 1, 2, and then over 1, 2, 3, that gets us right here. And this point is 0, 1. So our y-intercept is 1. How about this one? We're always going to start with y. This one is dashed and shaded below, so that's going to be less than. And then we need to find the slope. So difference of the y values, 3 minus negative 6. And then starting from the same point, negative 2 minus 1. So 3 minus negative 6, that's 3 plus 6, that's 9, over. Negative 2 minus 1, that's negative 3. 9 over negative 3 reduces to negative 3. So y is less than negative 3x, and then what's the y-intercept? Looks like it crosses at negative 3. Alright, we're done learning about graphing linear equalities. I will see you at the next class. Bye-bye.